AWS RDS service architectural capabilities. In the last section, we saw how we can launch a DB instance and how we can connect to the DB instance, create databases, create tables, and interact with the database. In this section, let's look at the RDS architectural capabilities in a little bit more detail. As part of this section, we're going to look at the performance, scalability, availability, configurability, durability, security, logging, monitoring, alerting, import-export of data, and the cost model characteristics of our AWS RDS. Let's look at the performance of RDS. Well, you have an AWS RDS instance ready to go. In our case, it's the MySQL instance, and we would like to performance tune it. Well, when it comes to performance tuning, RDS has some built-in defaults for the instance size. We saw that there is something called parameter groups, and those parameter groups have some default parameters for the database. They've done the best job possible for that particular instance. But of course, what we know our database better, the application developers know their database better, and so they have the opportunity to tune the DB server instance based upon the parameter values that they want to set. So it's possible to do that using parameter groups. It's also possible to add memcache using the DB option groups into MySQL database, so that also increases performance. When it comes to storage performance, you can choose the magnetic disk, or you can choose the more performant SSD storage. If you choose the magnetic disk, then you're actually looking at a database that is probably a smaller database with rare usage. Provides 3 terabytes of storage at most. So notice that there is actually a limitation when you actually use the magnetic. In terms of the SSD, for performance, you have two choices. You have general purpose SSD, which can go all the way from 3 IOPS per gigabyte to 3000 IOPS for up to 6 terabytes of SSD storage. If you go with provisioned IOPS, then you can go up to 6 terabytes of storage, but you can get up to 30,000 IOPS per instance. So the difference between the general purpose and the provisioned IOPS is the IOPS level. Here you get a much better IOPS, much better IO performance in your storage. So that's how you performance tune your AWS RDS MySQL instance. But it's important to note that the developers are also themselves responsible for the application performance. And there are several techniques that are available for application performance. For example, you can create indices, you can denormalize the database, you can use caching. So please understand the developers are equally responsible for improving the performance of AWS RDS database. In terms of scalability, there are two kinds of scalability. There is vertical scalability and horizontal scalability. Let's look at vertical scalability. Vertical scalability is achieved by changing the instance types. You can go from tiny instance to medium to large to extra large. These are all some of the different instance types that I'm showing you over here. You can choose whatever is applicable to you. You can also choose higher memory instance, higher CPU instance, higher IO instance, higher storage instance. So there are different kinds of instance that's available for your application. In terms of storage, you can go from EBS magnetic to EBS general purpose to EBS provisioned SSD. That is the provisioned IOPS storage. That's how you get vertical scalability. In terms of horizontal scalability, you get horizontal scalability by launching multiple read replicas. The idea here is that you'll have a master database and you'll have several read replicas that you would create out of the master, and your application can connect both to the master and to the read replica. You can connect to many read replicas. Typically you'll connect to one read replica. Here I'm showing you the application connecting to 2 read replicas. And the idea here is that your application will talk to the master when it wants to do write operations. So it's talk to the master for write operations, and it will talk to the slaves for read operations. When I say slaves, I mean the read replicas. That's how you get scalability of your application. In terms of availability, Going with the same model, we have the master database with the read replicas. By having the application connect to the master for writes and the read replicas for read operations, you can actually improve the availability. Even if the master goes down, you can go to the read replicas for serving read-only data. But if the master does go down, you can immediately bring the standby slave and make it into the master. That's the idea behind availability. So RDS optionally provides and maintains a standby replica in different availability zones in order for you to provide the availability. In this particular case, we have two database instances. This would be in availability zone 1, let's say, and this will be in availability zone 2. If the master crashes, the database instance in the second availability zone will be made into a master. The clients are referring to the database using the host name, and because the master basically takes the IP address, it basically takes on the IP address. Whatever the IP address that was there for the master will be taken over by the slave, so this takes on the IP address. And so when the client reconnects, they will end up reconnecting to the slave. In the same way, the read replicas are using the host name of the endpoint, and so they end up reconnecting with the new master in order for them to get the updates from the master. That's how the availability is done. So when the master crashes, the standby becomes the master, the slaves re-establish relationship with the new master. Some short service interruption may take place when the slave to master takes place. It may be a few seconds of slow performance. And then, but the reality is that the reads can still happen from the read replicas. Don't forget that the applications will have to re-establish connections to the database. And typically when you have a connection pool, the applications that are using the connection pool will re-establish the connection when a connection goes bad. In terms of configurability, there are two configurability groups that are available. There's the DB parameter groups and the DB option groups. DB parameter groups allow you to configure the database parameters, database tunings, and the DB option groups allow you to bring in new options into the database. In terms of durability is something we should talk about for any database. There are two approaches in terms of backup. There's the automated backup, which gets done on a daily basis at a specific time. There's also the manual backup that you yourselves can do, which is what is called snapshots. And if you're going to be doing backups automatically or in a manual fashion, you can restore from these backups. If you have automated backup, then you can restore point in time. If you have manual backup, then you can restore to the specific point of that particular snapshot. That's how backup and restore supports durability of the RDS database. In terms of security, it's possible to create RDS instance in VPC. In such a case, it's not assigned a public-facing IP address, and so it's only assigned a private IP. It's less prone to attacks in such situations, and many enterprises do that. They end up choosing VPC for their databases. You can also choose a DB security group to control access to the database instance if it's not in VPC, which is what we've been doing in this class. Possible to use encryption for connections. You can use an SSL certificate to encrypt, and it actually encrypts the connections. It's important to understand that it's encrypting the connections. So whenever a client is connecting to the database server, the communication is going to be over an SSL connection. By default, when you get a MySQL database, it's usually not encrypted. Especially if you're going to be opening up the database into the public network, it's probably a good idea to use SSL. Don't forget that encryption is compute intensive and so may increase latency of database connections. It's also possible to have encryption for data at rest. This is a very special feature of AWS RDS MySQL service. It uses what is called the AWS Key Management Service. It not only encrypts the data at rest, which is the data in the database, it also encrypts the data in the backup and also the read replicas and the snapshot. In terms of account, when you create an RDS instance, you get a very powerful user account, which is your root or the admin user account, with which you can do whatever you want. it's probably a good practice to use the master account to create a more restricted account, and that's what you hand over to the applications. In terms of logging, note that managed RDS does not give access to the instance, so they have to give you access to the log files through the console or through other API mechanisms, which is what they do, access logs through console or command line API. And for MySQL, you have access to the MySQL error running log, MySQL error running log based upon some backup times, 1, 2, 3, 4. I'm just showing you that you can get the 15th one if you want. There's also MySQL error log and also the MySQL upgrade log that's available. These are all log files that are available for you when you want to look at them in more detail. It is also possible to explicitly turn on slow query logs to see. Many MySQL database provides something called slow query log, but that is something you have to turn on using using special variables. And you can do that in your database, in which case it'll start generating the MySQL slow query log. In terms of monitoring, AWS RDS uses AWS CloudWatch to watch the DB instance that's being created. Monitoring can be done in terms of CPU, disk, memory, network. There are many aspects of monitoring that are available for you. You can also set or create alarms for notification. In terms of alerting, it uses AWS SNS, the simple notification service, to provide notification when an RDS alarm or event occurs. There are several events that are grouped into categories. There's availability, backup, configuration change, creation, deletion, failure, maintenance, notification, read replica, recovery, restoration, security, storage, full. These are all the various groups that are available, and within each one of these groups there are several events that can be tracked, and you can get notifications when such events take place. For example, when there is a configuration change, you can get an event. When the database is being created, you can get an event. When it's going through maintenance, so you can get an event. And the notifications can be in any supported form as supported by the SNS service. Can be SMS, email, or even a call to an HTTP endpoint. When an event occurs, you can ask it to hit an HTTP endpoint, maybe your application, which can react to that particular event. You can configure the events and subscribe to the events using the console, API, or CLI, which is the command line interface. In terms of cost model, the payment or the price is based upon several criteria. You pay based upon the DB instance hours, and the DB instance hours may be based upon the instance class. If you have a smaller instance versus a large or extra large instance, the price will be different. The smaller instance, of course, having a lower price. Of course, partial DB instance hours are also applicable. And then we talked about on-demand versus reserved instance. That still applies for the database instances. So if you want, you can go with reserved instances. That may bring down the price. And don't forget, separate pricing for multi-AZ. When you're using a multi-AZ, you have a master in one availability zone, and then you have another slave standby in the other availability zone. So you actually have two database instances that are running. Now, you don't really see the second database instance because there is no URL or hostname associated with it, but it's running. It shows up when the primary fails. They actually charge you for that too. So if you actually look at the multi-AZ pricing, it's almost double because there is another instance that's actually running there. You also pay for the storage per gigabyte based on EBS pricing. You pay for the data transfer. It's important to recognize that the internet data transfer into the database, there is no charge. But if your database is chatty, that is, it's going to be sending a lot of response back to the client onto the internet, because it's connected onto the internet, then you'll have to pay for the data out of the instance into the internet. So there's the data transfer out charge for which you have to pay. Continuing on the cost model, you pay for the backup storage. You pay for the backup storage associated with the automated and manual snapshot. Increasing your backup retention increases the backup cost. Let's say that you have 7 days of backup. That means you're going to pay for the 7 days of storage for the backup. If you increase it from 7 days to 21 days, then you're going to have 21 copies, so you have to pay for the 21 copies. But the good thing is that the first backup is free for active database instances. You have to be active for the first backup to be free. If that's the case, then you're only paying for 20 snapshots if you have chosen 21 days for your backup. It's important to note that 5 backups will mean 5 times the cost. If your database size is, let's say, 20 gigabytes, then each backup is going to be 20 gigabytes. So that means you have to pay for 5 times 20, 100 gigabytes of backup storage space. So the point I'm trying to make is every backup is going to be the same size as the original database size. So you have to choose your database size very wisely. You can always increase the database size, but you cannot bring the database size down. Importing and exporting data. You can use native DB tools for bulk import and export. For MySQL, DB import and export, you have MySQL dump, with which you can actually dump the database, and MySQL import, with which you can import data into the database. Those tools still work. If you're going to be bringing in data and lots of data, you can transfer the data onto an EC2 instance over the network and then use these tools like MySQL import to import the data. When you are going to be importing lots of data, something that you cannot really do over the network, you're welcome to ship the data using AWS import export service, where you actually send your USB hard drive to AWS and they will actually load it up into an instance. As far as other databases are concerned, Oracle has Data Pump, Import Export, or SQL Loader. That's their native DB tool that works. For SQL Server, you have the BCP tool, and for Postgres, you have the PG dump tool. So every database has their own tool and you can use them. In summary, when it comes to performance tune the DB using parameter groups and option groups. In terms of scalability, vertical scalability is achieved by launching bigger instances and better storage. Horizontal scalability is achieved using read replicas. Availability is achieved using multi-AZ deployment and read replicas, where the application reads from the read replicas and writes to the master. Configurability, using parameter groups and option groups to configure your database instance. Durability, achieved using automated backup and snapshots. Security, achieved using connection security, and also encryption using KMS, which is the key management service, uses SSL for both of them. In terms of logging, MySQL logs are available through the console or API. You cannot really log into the instance, so the best way is to go through the console or through the API or even through the command line to get access to the logs. Monitoring uses CloudWatch to monitor the DB instance. Alerting uses SNS to alert through email or text. Several events are also available. They are organized as groups. Cost model, cost for DB instance hours. There is cost for storage. There is cost for data transfer out to the internet. There's cost for backup storage. All these things will add up. And don't forget that higher price is what you pay for a multi-AZ instance. It's almost double. In terms of import and export, you can import or export data using standard tools. You can also ship drive to AWS for importing lots of data.